Right, question 2. So question 2a, they're all simultaneous equations. So your first question is x minus 3y is equal to 9 and 5x minus 11y is equal to 35. Can you see this okay on the board? Or do you prefer the other pen? The other one? Okay. So there are steps involved in this. I've given them to you in class. So the first thing you're going to do is you're going to multiply this top line by 5 and this bottom line by 1. I'm going to work down the page as opposed to across just to save a little bit of space. So you're going to have 5x. This 5 is going to multiply in here, here and here, minus 15y equals to 45, and the bottom line will stay the same because you're multiplying it by 1. Next step is going to change all the signs. Add like terms. So y is going to equal to 10 over 4, and it's minus 10 over 4. Are people okay with that? You can tidy that up a little bit more if you would like. Minus 5 over 2. That's a fairly standard answer, okay? So I'd be happy with that answer. So you're going to take that answer, you're going to sub it back into the original. So you've got x minus 3y is equal to 9. X minus 3 times y, so that's minus 5 over 2 is equal to 9. X plus 15 over 2 is equal to 9. So just slide this in here. So x is equal to 9 minus 15 over 2. X is equal to, I don't have a calculator with me, so that's 7.5. So x is equal to 1.5, or x is equal to 3 over 2. Okay, so there's your first question done, A. The next one, or well, II. It says A is equal to B minus 1, and 4A is equal to 3b. I think probably what you need to notice first of all is that any of the simultaneous equations that you've done so far have looked like this. Okay? In other words, it has been letter equals number. And of course that's a plus or a minus in there. So it would make sense that if you get something that looks a little bit different, it would make sense that you would reorganize that so as that what you're dealing with in terms of a simultaneous looks like letter equals a number, and then you can work forward with it. So A is equal to B minus 1. I'm going to rearrange that. I'm going to bring the B across, so A minus B is equal to minus 1, and this is what I'm going to work with in just a second. I'm going to take the 4A is equal to 3B. I'm going to say 4A minus 3B is equal to 0, and this is what I'm going to work with now. So I'm going to take the two of these down, and I'm going to start my work. So I've got A minus B is equal to negative 1, and 4A minus 3B is equal to 0. The fact that it's equal to 0 doesn't matter. 0 is as valid a number as any other. So I'm going to multiply the top line by 4, I'm going to multiply the bottom line by 1. Remember, there's a 1 there. So I'll be left with 4A minus 4B is equal to minus 4. Bottom line, 4A minus 3B is equal to 0. Change all the signs, so minus, plus, minus or plus, makes no difference. Tidy it up. 0A minus 1B is equal to minus 4. So just finish this here. So that means minus B is equal to minus 4. So B is equal to 4. And very quickly then you can just say, well, if you know, you take that B value, you sub it back in, and you'll get a value for a. So I'll just do that here. If I've got 4a is equal to 3b, 4a is equal to 3 times 4, 4a is equal to 12, a is equal to 3. Okay. Moving on to the b part. So you have to solve some equations. So the first one, part 1, says 7x plus 1 all over 5 is equal to 3. And what we've seen here, first of all I'll do it what are we actually doing mathematically, but then I'll show you I'll do the rest of the quick way that we normally do them. So strictly speaking, what we're doing is we're multiplying both sides by 5. So it's that this 5 and this 5 will cancel. 7x plus 1 is equal to 15. 7x is equal to 15 minus 1. 7x is equal to 14. X equals to 2. However, I'd say what a lot of you have copped at this stage is that you can go a little bit faster with these. In other words, this can just, obviously it's not that it just grows legs and walks up there or jumps up there. Strictly speaking, you're multiplying both sides by 7. But to save yourselves a little bit of work, you can just say 7 by 9. And the third part, now I don't think that's a difficult question, so what I'm actually going to do with this one is I want to show you a scenario where what's underneath the line cannot come up, because I want to make sure that you're clear on when you can and can't do that. You can only move this 7 up to multiply when this is a single. All of this is a single fraction. And it's a single fraction, just put it in red here, because of this line here. 5x minus 1, all of that is being divided by 7. Okay? Maybe if I give you an example of when you couldn't just move that 7 up. If the question looked like this, 5x minus 1 over 7 equals to 7, then it would not be appropriate to move this 7 up here. You're not allowed to do it. In order to solve that kind of a question, well, there's a couple of different ways, but I'm going to stick to the way we've tackled them before. In order to solve that, what you would do is put this over 1, you'd LCM it, so this would be all over 7, you'd multiply these two numbers, and then you'd crisscross. So 5x by 7, so it would be 35x minus 1 equals to 7. And then, because you've got it all over 7, then you could bring the 7 up underneath. Does that make sense? So you need to be very careful about when you move things that are underneath the line. Okay? It's only when you've got a complete fraction, a full fraction. So it's all being divided by a particular number. If it's indifferent, another way sometimes people look at it is, if there are two terms, well then you can move the 7, right? So this here would be classed as term 1, and this here would be classed as term 2. Whereas this question here, I'll just rewrite it for you because it's getting a bit messy. 5x minus 1 over 7 equals to 7. This would have 3 terms. Term 1, term 2, term 3. So if there are more than 2 terms, you can't move what's underneath the line particularly easily. Okay. Now there are other ways to solve that question, but I suppose I'm just concentrating on how you deal with what's underneath the line. I'm going to move on to the part C. So part C1, you've got x plus 1 all over 3 plus 3x plus 1 all over 5 equals to x. Now this is a perfect example really of what I mean. I can't just decide to move the 5 or the 3 up and multiply. It doesn't work like that. And another mistake I suppose that I wouldn't want you to make is, so this is just, no, you're not, this is incorrect. Sometimes what people would do is they've got x plus 1, 3x plus 1 is equal to x. And they know that the 3 and the 5 can sometimes move like that. They can sometimes go up, and what they do is 3 times 5. That's still incorrect. Okay? So that's not appropriate. And it's incorrect because you haven't multiplied these two terms by your 3 and your 5. Okay? But let's not. We won't get bogged down. I'll put it to you this way. Even though there's some algebra in this question, what you can see is there are 3 terms. So what we want to do is we want to pull 2 of those terms together, and then we can take what's underneath the line and just move it on up. So what we'll do is we'll do this the way we've seen before. We multiply the 2 bottom numbers. So that's going to be 15. And then we'll just crisscross. So we'll say 5 by x plus 1. I'm just writing it in a way that I'm used to. Plus 3 by 3x plus 1. I'm going to tidy up that top line. 5x plus 5, 9x plus 3. And of course that's coming from just multiplying it. Don't drop the 15. It's still all over 15. 5x and 9x, that's 14x plus 8 all over 15. And then what you do is you just drop this down. It's equal to x. Now, I suppose strictly speaking, you should really drop that down all the way. But sometimes if you start doing that, people do get a little bit sidetracked by it. Now that you've got just 2 terms, basically this 15 can just be popped up here. 14x plus 8 is equal to 15x. 15x minus 14x is equal to 8. X equals 8. So I'm going to do one more, the last one there. Part 2. Now the layout of this, again, if you have a look at it, move things around to make them look the way you're used to dealing with. The fact that there are 3 terms on the left hand side, there is a way to deal with it, but it's not how we have learned how to do it. So what we're going to do is we're going to change the way this looks. We're going to say 9 minus x over 6, x plus 1 over 2 is equal to minus x. So I've got 2 terms on the left hand side and 1 on the right, and that's what we're used to seeing. So I'm going to simplify it. Now, guys, the temptation here is to use a 6 underneath the line. In order to avoid confusion for some of you, what I have done, I've tried to make this as simple as I can. If you're going to use my method, you do not choose the LCM. You just choose a common multiple, and that common multiple is given by multiplying the 2 bottom numbers. So in this instance it's 12. So I'm not choosing 6. Okay? So then you can just crisscross. So it's going to be 2, 9 minus x minus 6, x plus 1. Tidy it up. 18 minus 2x minus 6x minus 6. Will you watch out for, see this one here, the minus 6 by the plus 1. Quite often people put that down as plus 6. They forget that the number on the outside is minus 6. And it's all over 12. Going to tidy it up a little bit. Minus 8x plus 12 all over 12 is equal to minus x. Now this 12 can come up and multiply. Minus 8x plus 12 is equal to minus 12x. I'm going to bring this, well, doesn't matter what way you do it. I'm going to bring the minus 12 across to the left hand side because I like to have them positive. So that will be 4x plus 12 is equal to 0. 4x is equal to minus 12, so x is equal to minus 3. That, as they say, is that.